Now that we looked at the graphs of radical functions, what we're going to look at now is solving radical equations. So all of these equations are now going to contain either a square root or a cube root. So as I said, radical equation is an equation that contains a radical expression with the variable in the radicand. And what we're going to do is go through a bunch of different examples, and the way that you would solve a square root is the same way you would solve a cube root. So you're using properties to isolate the radical on one side of the equation, and then from there, if it's a square root, you're going to square both sides to eliminate the radical. If it's a cube root, you're going to cube both sides to eliminate the radical. So for example, we need to isolate our radical. So we want to isolate the square root of x. So you're going to subtract 5 from both sides. Doing so, now you're left with the square root of x equaling 8. In order to eliminate the square root, you're going to square both sides. Squaring both sides cancels out the square root, just like when you had x squared and you could take the square root of both sides. This is now the opposite. So you're going to square both sides, and now you get 64, and you solved for x, and that is your final answer. So again, you're isolating your radical, and then from there, you're squaring both sides or you're cubing both sides. So again, before you can square both sides, you need to isolate this radical. So we are going to subtract 3 from both sides. So 19 minus 3 is where we're getting 16. Then we need to get rid of the 4. Never distribute. Divide. So you're going to divide both sides by 4. Don't touch the radical at all. So that's why you're dividing. Do not touch the radical. Then, to get rid of the square root, you need to square both sides. So now we're going back to 16. Now, before, once you took you squared both sides, you were done and you found your answer. Well, we still need to solve for x. So after you square both sides to get rid of the square root, now you need to solve for x by subtracting 2, and then you get 14. So x equals 14. Okay, third example. Now what happens when you have square roots on both sides? So in order to eliminate the square root on the left, you want to square both sides. And what happens is when you do that, both radicals actually get eliminated because you're squaring both of them. Because what you do to one side of the equation, you have to do to the other, and they both cancel out, leaving you with just leaving you with a multi-step equation that you did in 8th grade and that we did in September. So from there, solve for x. So you're going to subtract x from both sides, and you're going to add 1 from both sides, and you solve for x by getting x equals 5. Now, this example, same thing. You want to square both sides to get rid of your square root. And when you do that, you're going to square your x. Now you're left with x squared equals x plus 6. This now ties in chapter 9, where we were solving quadratic equations. Set it equal to 0, so you can either use your quadratic formula or factor. So you're going to subtract x, subtract 6, set it equal to 0. Now from there are factors of -6 that add to -1. So you can factor this, and you do not have to go through the whole process of using your quadratic formula. So by factoring, you get x minus 3 times x plus 2. Set them both equal to 0, and you get x equals 3 or x equals -2. Now you have 2 possible answers. So what's going to happen is you want to check both of them. Because when you check them, you're going to find out that one of them is called an extraneous solution. That it looks like it's the right answer, but when you go to plug it in, it is not the right answer at all. So the only real solution is x equals 3. Because when you take -2 and you plug it in, -2 does not equal +2. So that is called an extraneous solution. So anytime you're solving radical equations and you get 2 answers, you want to check them. If you're getting 1 answer, there's no need to check them. But if you're getting 2, you need to check both of them because one of them might be an extraneous solution. So again, what is the root word of extraneous? Extra. It's a solution that appears to be correct, but when you go and check, it's not correct. And that is all for solving square roots and cube roots. So again, if these were cube roots instead of square roots, you would cube both sides instead of squaring both sides. But the whole process is the same as well.